My subject, though, is a somewhat grim subject, but it's one that we all are in the midst of. So I venture into it and invite you to venture into it because it is such a compelling subject, such a crucial one in our time. According to NOAA, the National Oceanic and Atmospheric Administration, the planet has just come through the warmest decade, the warmest 12 months, the warmest 6 months, and the warmest April, May, and June on record. So far, 9 nations have set their all-time temperature records in 2010, and warmer seawater has reduced phytoplankton, the base of the marine food chain, by 40% since 1950. Glaciers worldwide have lost more than 2,000 cubic meters of water since 1960, which has contributed to the observed rise of sea level, which is still quite small relatively, but gaining momentum. What's the cause of the temperature rise? Well, the dominant theory among climate science is that it's anthropogenic. And the anthropogenic source of the increase in temperature is indicated first by the close correlation between the rise in greenhouse gases and the rise concentration and the rise in temperature associated with a plausible mechanism by which the increased intensity of greenhouse gases raises the temperature, but is confirmed by the vertical temperature profile of the atmosphere that corresponds to greenhouse gas intensity as cause, and does not correspond to the sun as cause. So that is, the two heat the atmosphere with quite different profiles. This analysis, incidentally, was published in the mid-90s by a climate scientist named Ben Santer. About these issues, there's a very high degree of consensus among climate scientists. For example, a recent study at Stanford University showed that 97 to 98% of the climate researchers most actively publishing in the field support the tenets of anthropogenic global warming outlined initially by the IPCC. And 2, they show that the relative climate expertise and scientific prominence of the researchers unconvinced of anthropogenic global warming are substantially below that of the convinced researchers. Efforts to estimate the human cost of these climatic changes are, of course, even more difficult, and here much less consensus prevails. But nonetheless, even if we cannot put numbers to the cost, most analysts agree that it will be high, very high. Even a 2 degrees centigrade increase in average temperature will incur very high human costs, and it has become increasingly clear that we have already missed our opportunity to limit the planet to a rise of 2 degrees centigrade. We also know that for higher temperature increases, for example, for an increase of 4 or more degrees, estimated, we'll soon see the slide, estimated with a probability of 87% in the course of, along the course we're now proceeding on, the likelihood of catastrophic consequences rises precipitously. As the title of a recent article in the PNAS asks, is it time to stop worrying and start panicking? The irony is that this summer, the hottest on record, the US Senate declined to even consider legislation to regulate greenhouse gas emissions. Many took that decision as a devastating defeat, as did I. Homer Dixon, for example, wrote, "Climate policy is gridlocked, and there's virtually no chance of a breakthrough." Many were also outraged by this failure. Paul Krugman wrote an article entitled, "Who Cooked the Planet?" in which Krugman argued that we did not fail to act because of doubts about the science. According to him, every piece of valid evidence points to a continuing and quite possibly accelerating rise in global temperatures. Nor, he wrote, is this evidence tainted by scientific misbehavior, as some skeptics might claim. Every one of these supposed scandals was eventually unmasked as a fraud concocted by opponents of climate action and then bought into by many in the news medium. Perhaps there's still time to reverse our stance, to do what needs to be done, and if so, clearly a better understanding of how we came to our current impasse ought to help us extricate ourselves. There isn't a light here, isn't by chance, is there? I can sort of read. She said she'd be just outside.
Yes.
Let's just ask her. So. But even if we cannot influence the future, I think, being a stubborn intellectual that I am, I think we still need to understand how it is we came to where we are. And for this, pointing to greed and cowardice is just not enough. The factors that contribute to our current impasse are many, and they pose exceedingly difficult problems. They may not be unique to climate change, but they have particular salience here, and I think it's just possible that philosophers might be able to help. So just a little bit more about predictions. An extensive study just released by Stanford predicts a dramatic spike of extreme temperatures during the current decade between just the current decade, that's 2010 to 2020, the following decade, 2020 to 2029, an intense heat wave equal to the longest on record from 1951 to 1999, as likely to occur as many as 5 times, with yet hotter temperatures in the following decade, when the 2-degree rise of temperature is expected to be reached. But virtually no one expects the rise in temperature to stop at 2 degrees in the absence of substantial regulation. And this is where I have this slide, which is down here. So this is a figure that is very user-friendly, that represents the predictions of sort of a summary of climate science models. And it predicts, it refers to 2 different scenarios. On the left, business as usual, the cost of inaction. And on the right is the consequences if we immediately implement serious regulations. And the color of each pie slice represents the degree of warming anticipated. So you can see the likelihood by the end of the century, the probability estimated of a temperature increase of less than 3 degrees is less than 1%, according to these models. And while the probability of an increase of temperature of more than 4 degrees is roughly 87%. But however, with a regulatory policy in place, the odds change very dramatically, while the probability estimated for a temperature of more than 4 degrees becomes negligible, 1 to 2%. Okay, so the 2 problems I want to focus on are, the first one is the difficulties of estimating the costs of inaction. This figure, which comes from a study at MIT, provides us with probability estimates of various degrees of temperature increase. We have here not only 87% probability of a temperature increase of more than 4 degrees, but even more worrying, a probability of about 60% of a temperature increase of more than 5 degrees. These models also tell us that rising temperatures increase climate instability, giving rise to more frequent and more extreme events like hurricanes, heat waves, floods, etc. But as yet, they have not been able to project estimates of the size of such effects over long periods. And so far, the Stanford study that I just referred to you is the best. Similarly, climate scientists generally agree that the kinds of feedback known to be important in the climate system can trigger irreversible changes, even runaway global warming. But it's extremely difficult to say exactly where such points lie. Even the ultimate catastrophe, that is, a course of events that would lead to an uninhabitable Earth, cannot be ruled out, but it is probably impossible to say just how much greenhouse gas the atmosphere can tolerate before such a course is triggered. Even tipping points of a more local kind are fraught with uncertainty, but these may be a bit more accessible. For example, a number of glaciologists have argued that a temperature rise of 2 degrees is a tipping point that would likely lead to the melting of the Greenland's ice sheet by the end of the century, which in turn would result in a global rise of sea level of about 23 feet. And some eminent climate scientists claim that the present GHG, greenhouse gas levels, already commit us to passing 2 degrees. But as I say, all such predictions abound in uncertainty. Furthermore, these predictions concern only the future climate, assuming, that is, we continue on our present course. If we want to try to estimate the costs of inaction, the human costs of inaction, all these numbers, together with all their uncertainty, have to be translated into their effects on human lives and well-being. And this is where the really difficult problems arise. Climate effects are not evenly distributed around the globe, and neither is population. People living in coastal areas are obviously more vulnerable to rising sea levels than those living in higher elevations. Those living in agricultural regions more vulnerable to drought. Those in regions already so hot as to be barely habitable more vulnerable than the inhabitants, say, of Siberia, which some analyses strongly recommend you buy property in because the value is expected to soar. Furthermore, just as temperature increases trigger many kinds of positive feedback, like, for example, the release of methane from the melting of permafrost, so too do they trigger social problems with at least equally massive snowball effects. Drought leads to famine and the shortage of drinking water. The shortage of drinking water encourages resource wars. Flooding leads not only to high death rates, as we have just seen in Pakistan, but to raging epidemics, homelessness, and massive dislocation. Dislocation in turn leads to border problems, even border wars. Large death rates lead to a breakdown of infrastructure that harms and kills even more people, and so on. As Cass Sunstein notes, the effect of a catastrophe greatly outruns a simple multiplication of a certain number of lives lost. All of which drastically magnifies not only the consequences but also the uncertainties, making the quantitative assessment of risk virtually impossible. How then can economists estimate the cost of catastrophic events? The first difficulty that climate change poses for economists comes from the fact that the effects of global warming are in the distant future, hurting future generations far more than they're likely to hurt us. This gives rise to the immensely fraught problem of intergenerational discounting, how we weigh the lives and welfare of future generations relatively to our own. The standard approach in economics is to discount the value of future generations as much as we discount short-term bank loans. But using a conventional discount rate of 5% leads to the absurd conclusion that a billion lives 500 years from now are worth less than a single life today. Yet, when Nicholas Stern in the Stern report insisted on these grounds that we take a discount rate that's close to zero, he was widely criticized for importing ethical considerations into his calculations, a cardinal sin in economics. Furthermore, Martin Weitzman has been arguing for some years that even more unsettling than the problem of the discount rate, of discounting the future, are the unknowns and uncertainties of global warming. Climate science tells us that a catastrophe for planetary welfare is non-negligible. The risk of a catastrophe is non-negligible, but they cannot tell us its probability. The standard approach economists have taken is to assume such events are distributed normally and to ignore extreme outcomes on the assumption that they are outliers, that is, their likelihood is extremely low. But climate catastrophes are not distributed normally. Weitzman and others argues that the probability distribution of such outcomes is far more plausibly fat-tailed, was thicker, much fatter than the normal distribution would be, and therefore, for that reason, cannot be ignored. Furthermore, the magnitude of their effects means that taking them into account, and Weitzman suggests how we can do this, dramatically changes conventional economic assessments, indeed leading to cost estimates that are far closer to those of the Stern report, 1 to 6% of the current GNP, than they are to the figures that were fed to the legislature that decided to withdraw legislation for regulation. Weitzman's models do not invoke ethics. They simply require taking extreme events seriously. But even Weizmann may not be sufficiently critical, for he accepts the conventional view that the probability of extreme temperatures is small. But we look at this graph, already 5% is a pretty extreme temperature, 4% is a pretty extreme temperature, and the probabilities are not small. The second set of problems I want to talk about is alluded to both by Kruger's reference to scientific misbehavior and to my earlier remarks about the dependency, earlier remarks which you didn't hear, about the dependency of legislative action on what voters believe to be the case about climate change, in which I argued it's not reasonable to attribute the Senate failure simply to greed and cowardice, where the U.S. Senate and our representatives, and according to recent polls, a large proportion of the population does not believe climate change is real, and an even larger proportion discounts the view that it's anthropogenically caused. The responsibility of our congressional representatives is to represent our views. So on what grounds can we legitimately expect the Senate to vote for precautions that the population is not willing to pay for? That they're not willing to pay for these regulations is, of course, a consequence of what the expected costs, what they are told, advised these regulations will cost. And these regulations, so this brings us back to, in full circle, to the responsibility of economists here. Okay. So why does the population of voters, why are the voters so skeptical? Why are they so misled about the dangers of climate change? And of course, we know about the campaign that has been waged for years to discredit climate scientists, a campaign incidentally explicitly modeled on the campaign designed and promoted by the tobacco industry in the 80s. Climate to spread doubt, to discredit the scientific claims by invoking the uncertainty of these claims, and to doubt and to distribute doubt of the climate, of the qualifications of the climate scientists. Into this strategy came, or as part of this, out of this strategy came the infamous events of ClimateGate, where the email records of a prominent climate science department were broken into and were grossly abused by the press, misrepresenting the actual communications. The second event of climate change, of course, was the infamous mistake of the IPCC report, a mistake that was actually on something like page 486 of a subcommittee report. It was not a subcommittee of the climate scientists, incidentally. It was a social scientist that misrepresented the danger, the speed at which the Himalayan glaciers are melting. This was taken as cause celebrity. It was invoked. It was invoked by the press, by many people in the Senate, by the right-wing talk shows, as grounds for discredit. Well, I don't want to. I'm a little confused about my talk. Okay, let me just say that as a result of these events, confidence in the expertise of scientists is now at an all-time low, with much of the internet, radio talk shows, and popular television deluged with challenges to the credibility and trustworthiness of climate scientists. In an effort to adhere to their traditional ethic of balanced reporting, even our most prestige newspapers and journals have contributed to the confusion by spreading the widespread misimpression that climate scientists are deeply divided about both the extent of the dangers we face and the relevance of human activity to global warming. Not knowing who or what to believe, the natural response of most people is to do nothing, leaving the field to the rabid contrarians on the one hand and the few climate scientists who are willing to engage in the public disputes on the other, clearly an uneven contest. After ClimateGate, the state of Utah passed a resolution calling on the Environmental Protection Agency to immediately halt its carbon dioxide reduction policies until a full and independent investigation of the climate data conspiracy. And this summer, a resolution requiring the EPA to overturn its endangerment finding just narrowly failed to pass in the Senate. Public opinion polls show a conspicuous decline in the number of people who believe climate change is occurring, much less from human activity, and a doubling since 2008 of the number of Americans who believe that climate change was a hoax or scientific conspiracy. The inimitable Glenn Beck has suggested harakiri for dishonored climate scientists, and Russ Limbaugh that they should be named and fired, drawn and quartered. And prominent scientists have been, like Ben Center, have been deluged with hate mail and even death threats. Climate scientists are dumbfounded, as is much of the larger scientific community. Nothing in their training has prepared them for such an onslaught, and they are in a deep, deep quandary. Should they weigh in on an issue that has become so conspicuously and vitriolically politicized? Would not their doing so compromise their claim to scientific objectivity and hence undermine their very credibility? What are they to do? Until recently, the main response of climate scientists has been to reassert the strength and legitimacy of their evidence and to dismiss their critics as scientifically illiterate. But with the escalation of attacks, many have come to feel the need to engage their critics, admit mistakes, and open up their data and reshape the way they conduct their work. These are all quotes from the New York Times. In response to ClimateGate, a session entitled Ensuring the Transparency and Integrity of Scientific Research was co-organized at the last annual meeting of the AAAS by National Academy of Science President Ralph Cicerone. While clearly critical of the media's role in sensationalizing these events, participants agreed to accept their share of the blame, acknowledging carelessness and the need for greater oversight on the part of the IPCC. As John Broder reported in the New York Times, scientists, quote, are learning a little humility and trying to make sure they avoid crossing a line into policy advocacy, quoting Cicerone as saying that they must do a better job of policing themselves. This response has been seen as indicating a new willingness among scientists to engage their critics, but I, for one, find it dismaying. I'm all for greater engagement with the public, but propitiation is not engagement. The confidence of the public in the findings of climate science may have been shaken, but that of the scientists themselves was not. They well know how much scientific work depends on seat-of-the-pants judgments about both data and strategies, and they are acutely aware of how these events have been manipulated and how blatantly political the aims of such manipulation. Why then such defensiveness? Of course carelessness is to be avoided, and of course vigilance is required to guard against the intrusion of witting or unwitting bias. What I find so astonishing was the apparent willingness of responsible media and some scientists to accept the incidents, the embarrassing emails, for example, or even the so-called error found on page 493, not 483, of a working report of the IPCC subcommittee as indicating misconduct, rather than, say, as evidence of the human nature of scientific inquiry. Also, nowhere in these reports did I find a reminder that the IPCC error that slipped through did so in the face of and in spite of an extraordinary and probably unprecedented system of oversight that was built into the IPCC rules of procedure. My own reading is that the presence of such an error is evidence not of misconduct, but of the fallibility of all systems of oversight, however rigorous and demanding. In my view, scientists do share some of the responsibility, but not for misconduct. Rather, they share responsibility for hanging on to an image of science that is not only unrealistic, but one that leaves them particularly vulnerable to attack. I'm referring, of course, to the image of science as infallible, as capable of delivering absolute truth, and as free of political value. At least amongst themselves, most scientists recognize this image of science as unrealistic. Yet they continue to invoke it when addressing non-scientists, and especially around issues that have become politicized. The same image is also invoked by political scientists in discussions about the proper relation between climate science and politics. The task of scientists, they say, is to determine or to make positive claims about what is, while the task of politics is to decide or make normative claims about what ought to be. In other words, what follows from what is the case that we as citizens ought to do. Similarly, this image has provided the framework for a wide range of discussions about the role of science in democratic society, about the nature of scientific responsibility, and about the proper relation between scientists and the larger public, their advisors, and between advisors and policy. Take Roger Pielke, for example, Roger Pielke Jr., who's a political scientist specializing in environmental policy, who claims that we need to put into place mechanisms, this is a quote, that somehow ensure the purity of science, so that scientists might deliberate unaffected by external values, pursuing only the truth, close quote. The only responsibility scientists have beyond their own technical domain, in this view, is to alleviate conflicts between science and society by providing more effective dissemination of information, that is, increased scientific literacy. Indeed, such views seem only to have been reinforced by the recent attacks, as a distressing number of climate scientists are retreating ever further into the sanctuary of peer review, seeking protection by this so-called boundary between science and politics. The problem is, this boundary is an illusion. Even Pielke admits that, quote, such a quaint utopian view of science and decision-making has been thoroughly rejected by scholars who study science and politics, and he quotes Sheila Jasanoff as writing, studies of scientific advising leave in tatters the notion that it is possible in practice to restrict the advisory practice of technical issues, or that the subjective values of scientists are irrelevant to decision-making, close quote. Indeed, nowhere is this illusory nature of such a boundary more evident than in climate science. And yet it persists. And in persisting, I suggest, does considerable harm. First, I suggest that expectations of certainty and value neutrality are responsible for much of the confusion that rages in the public understanding of climate science. And second, I suggest they are playing a major role in inhibiting climate scientists from responding effectively to the challenges they now face. One obvious way in which misapprehensions about the nature of scientific practice leaves climate scientists vulnerable is in inducing expectations of certainty. No scientific analysis is immune to uncertainty, but the ways in which uncertainty enters the analytic process multiply dramatically with the complexity of the problem under study. And as everyone knows, climate change is an especially complex phenomenon. Even after decades of study, our understanding remains far from complete. Climate is the product of a huge number of variables interacting over long periods of time in extremely complex ways. Efforts to understand this process, to determine what variables are most important and how they interact, depend both on empirical measurements of relevant variables and on best guess models of the physical dynamics governing their interaction, with constant exchange between these two activities. The models themselves are not only enormously complex, but they depend on frequent seat-of-the-pants judgments and are thus incapable of yielding certain predictions. Even so, even with all their with all the frailties, they give us our best chance, maybe our only chance, of anticipating the future. They don't tell us what will happen, but often they can provide us with estimates of what, under various scenarios, future climates are likely to have in store for us, and with what odds, as we have seen. Lay readers expecting definite answers from science are bound to be disappointed, but not so the scientists who work on such problems. They well recognize that they're not in the business of providing proof, and even when informally invoking the language of proof and truth to refer to their most robust findings, we finally nailed the anthropogenic cause of global warming. They by and large recognize that way of speaking as a shortcut for claiming evidence strong enough to warrant a working assumption of truth. True enough, the words of Catherine Elgin. Of course, judgment of just how strong the evidence needs to be for this purpose will vary, and areas of disagreement are inevitable. But my point is that while scientists are generally not bothered by the absence of certainty or proof, their confidence in their ability to contribute to the overall progress of scientific knowledge does not depend on the lack of certainty and proof. It suffices to be pretty certain. Nor, for that matter, do they require complete consensus. For most purposes, rough consensus serves well enough. This rough consensus is generally reached within the boundaries of a scientific community by practices of open deliberation, collective criticism, and peer review. Indeed, it is because their claims have survived so much scrutiny that climate scientists have as much confidence in their measurements, their calculations, and their predictions as they do. But in relation to outsiders, scientific authority is frankly elitist. Traditionally, the right to criticize has been limited to those with sufficient training and research experience to evaluate the relevant evidence and arguments, that is, to members of their own disciplinary communities, to peers who share similar viewpoints and make similar assumptions. And the obvious question arises, why should outsiders share their confidence? What, for example, if they're wrong? As we know, scientists, predictors of alarmist predictions of doomsday have been wrong many, many times, coming from scientists or elsewhere. But what worries so many climate scientists is not the possibility that they could be wrong, but the magnitude and seriousness of the implications of their finding should they be right. No one knows how bad things could get, how hot, how inundated, how drought-stricken, how unstable. Nor can anyone say whether the cost in human lives by the end of the century, should we fail to act now, is likely to be in the tens or hundreds of millions or even billions. We only know that the most likely cost of inaction would be horrendous. Indeed, it is precisely the magnitude of these consequences that distinguishes climate science from other clashes between science and politics that are sometimes invoked as parallels, for example, evolutionary theory, theories of planetary motion, or even breast cancer. When push comes to shove, how much in fact hangs on what people believe about evolution, or even planetary motion? Breast cancer, you might say, is another issue, for here the link between belief and mortality is immediate. Whether women believe that mammograms are efficacious or not will influence their decision to get mammograms. But the number of people at risk for adverse effects of one policy about mammograms or another, or the other, is minuscule compared to the number of people put at potential risk by a policy of inaction with respect to climate change. Maybe the worst case scenarios will never come to pass, but the question is, how large a risk are we willing to tolerate? How much devastation are we willing to risk? These are clearly political questions, and they are urgent political questions, but they cannot be addressed without a credible assessment of how much devastation, or at least roughly how much devastation might occur, and roughly how likely. But we're not asking this question of how much risk we're willing to tolerate. Indeed, this is precisely the question that is muted by the campaign to undermine climate expertise. So what are climate scientists to do? Convinced that they are the only ones with sufficient expertise to distinguish between information and misinformation, they are generally dismayed by the diffusion of so much blatant disinformation. But if their testimony is not credited, if readers do not have confidence in their expertise, what can they do? Expertise is their starting point. It is an unfortunate phrase I wrote, is their ground zero. But it's their starting point, it's their base, it's their ground base. It is the reason for their insistence on resolving their own disagreements internally. Peer review provides their formal gatekeeping mechanism, the one that both ensures a baseline of reliability and grounds their claim to scientific authority. But peer review is clearly, as we are seeing, not enough. The view of scientific authority as resting exclusively on internal evaluation obviously discourages direct confrontation with critics in the public arena. First, there's no guarantee that their authority extends beyond their technical domain, that the audience will believe them. And second, insofar as that authority depends on separating science from politics, venturing into the public domain threatens to undermine their credibility. Yet recourse to peer review, on the other hand, leaves the dissemination of misinformation in the lay press unchallenged. While the great majority of papers published in peer review journals support the conclusions of the IPCC, these journals are not read by the audience of readers that climate scientists most need to reach. Such audiences may vary enormously, but they have one important feature in common, and that is their insulation from the professional literature, from this community of free exchange, dialogue, mutual criticism. In fact, it is precisely this insulation that permits the rampant skepticism we are seeing. There are also other problems. Does the internal regulatory system of scientific disciplines suffice to exempt their claims from all external criticism? Can no one from outside raise objections, register doubts, engage in productive criticism? Not even Freeman Dyson, who in the New York Review of Books has weighed in on the side of the skeptics? Just how much expertise must a reader have in order to legitimately engage in critical review? And how is a reader without expertise to distinguish between legitimate and illegitimate criticism, information and misinformation? The difficulty is that we lack an adequate alternative to our traditional assumptions about these matters. How should we think about the interplay between science and politics, and accordingly, about the place of science in democracy, as Phil Kitcher has written so well about? What are the implications of research, where the implications of research are as huge as they are in climate science? It seems to me inevitable that the distinction between legitimate and illegitimate criticism becomes intensely politicized. Yet at the same time, it is precisely because of the magnitude of the implications that such distinctions must be made. I take it as self-evident that we cannot do so without the help of experts. But at the same time, we need to think more about how much expertise is required for legitimate criticism and about what ought to count as expertise, and about why it is trustworthy. To quote Jasanoff again, contemporary democracies depend for their robustness, not to say their very survival, on the wisdom of strangers. But how do we know which strangers to trust? Special knowledge or skill, expertise, and training is surely part of the answer, but Jasanoff also reminds us that as members of a democracy, we trust experts because they supposedly represent our interests and are accountable to us. Accountability, I think, is the key. Stephen Turner, citing Carl Schmitt, from the early part of the 20th century, argues that expert claims are political to the extent that they, quote, affect, combat, refute, and negate some faction or grouping of persons. By this criterion, claims about human contribution to climate change are inherently political. The word, I put the word in political in quotes because of Turner's insistence, again following Schmidt, that what is political is a political question. Making something scientific or true does not mean making it non-political. Fair enough. That's what Turner insists. Fair enough. But we cannot stop here. We must also know the converse. Making something political does not mean making it either non-scientific or not true. Indeed, it is in good part just because politics, in Turner's sense of what advantages or disadvantages different groups of people, such politics depend so critically on scientific facts that the relations between science and politics are as fraught as they are. Quotation marks are necessary here too because calling something a fact can itself be a political move. If what science deals with are not facts in the sense of that being absolutely right or wrong, but rather the product of our best efforts at getting it right, and hence always subject to some degree of uncertainty, Turner's own parsing of facts from uncertain claims and beliefs not only does not hold, but is also something of a red herring. It's not that scientific reasoning does not depend on beliefs, ideas, guesses, and uncertain inferences, but rather that the beliefs, ideas, guesses, and inferences are informed. They are constrained by what is known of those facts of the matter that researchers are trying to get at, and they are subject to ongoing critique and possible refutation, amongst themselves, that is. These formulations, their formulations, their beliefs, their estimates, inferences, and mutual criticism are essential parts of their efforts to get it right. These are the rules of the game of science. Similarly, in the normal course of events, policy is warranted not only by demonstrable facts, but also, and more commonly, by estimates of what is likely to be the case, by inferences from available data, and even by informed guesses. Military policy, economic, health, and welfare policy cannot afford to wait for proof. Policy must be formulated on the basis of the best information available. Were the experts on whom policymakers relied to recuse themselves whenever they didn't really have the facts, as some political scientists have suggested, policymaking would be in a sorry state indeed. Why should the making of climate policy be different? Similarly, if we accept the definition of political as that which affects people, the magnitude of the social implications of climate change implies that there is no way to separate the scientific claims from their political implications, just as there is no separating political arguments from assertions about what is or is not the truth of the matter. In other words, where the results of scientific research have a direct impact on the society in which they live, it becomes effectively impossible for scientists to separate their scientific analysis from the likely consequences of that analysis. Perhaps we would better manage the tensions between expertise and democracy if we gave up the effort of disentangling science from politics and instead recognized our political need for the special expertise of climate scientists, just as we recognize our need for expertise in all other areas of our lives. But just as elsewhere, our confidence in the authority of experts needs to be earned. The particular authority that accrues to climate scientists is clearly based on their skill and experience. But authority requires more than the fact of expertise. It also requires legitimation of that expertise. And that legitimation, at least in the US, is normally provided by peer review, back to peer review. Insofar as it rests on the approval of their own community, their authority resides in that community. How then can the authority of climate scientists be extended into the public domain? And if it can, what new responsibilities does such an extension entail? Now, discussions of scientific responsibility often begin with questions about a scientist's responsibility to other scientists. That is, with issues of scientific integrity, They must not fake their data, they must not misrepresent their observations, they must not misreport. But when the implications of their research so directly concerns the larger population as they do here, scientific responsibility needs also to include obligations accruing first from the trust that the public has invested in them qua scientists, that is to deliver them the most reliable knowledge of which they're capable, and second, as custodians of a public good, by which I mean the science they produce. Scientists have an implicit contract with the state that funds them, and it is this contract that makes the products of their labor a public good. And because it is a good that is, at least initially, under their own control, they need to bear responsibility for that good, at least for as long as it remains under their control. In other words, I'm saying that scientists are obliged to ensure safe delivery of the good they have produced into public hands. And I'm arguing that accordingly, their responsibility qua scientists, that is their scientific responsibility, goes far beyond concerns about professional integrity. It includes as well the obligation to share the results of their expertise with those likely to be affected by the implication of those results. They can't just leave it as, well, here it is, take it or leave it. They have to guarantee that they are heard and understood. How is this obligation to be discharged? And how can it be discharged without undermining the scientist's hard-won claim to disinterested objectivity? Many scientists worry that any venturing out into the public domain beyond the authorization of peer review might in itself jeopardize their credibility and authority. Is this a legitimate concern? Let me return to the issue of what a scientist's authority is based upon. I started out by accepting the prevailing view that it comes from the validation of their disciplinary community. But there's no obvious reason why such validation should automatically endow experts with authority in the world at large, that is, with the public authority that is now so woefully lacking. I want, therefore, to suggest that seen from outside the scientific community, the disciplinary community, the legitimation of scientific authority requires rather more. Unless I'm willing to accept someone else's authority on the basis of third-party say-so, I need direct convincing. And in the absence of technical expertise of my own, I need to be persuaded both of that person's honesty or credibility and of the cogency of his or her argument. Within the scientist's own community, validation and respect is won on the basis of sound arguments and authenticated evidence. Why cannot these same considerations also legitimate authority outside their own community? Is technical expertise really necessary for educated readers to distinguish between good arguments and bad? Between carefully collected and well-scrutinized evidence on the one hand and conspicuously flimsy evidence on the other? The standard response to the problem of public understanding of science is increased scientific literacy. But I want to argue that more to the point would be, well, I call it increased articulacy on the part of scientists, but that's not an adequate word. That is, an increased effort to make their arguments, their doubts, and the reason for their concern, the reason for their convictions, intelligible even in the absence of technical expertise. And I claim that doing so is almost never as difficult as it is generally assumed. Disagreements and uncertainties are abundantly familiar territory to most readers, and examples in which technical arguments are made accessible are similarly not hard to find. But effective communication also requires an ear. It's not just articulacy, it's an ear that scientists need to develop for what readers need to know. And one thing they need is to be able to follow the process by which so many climate scientists have reached the conclusions they have, despite the limitations of their knowledge and the uncertainties of their projections. Of course, the lay reader can generally not make the fine distinctions that a professionally trained reader can. But even so, he or she is quite capable of making the sorts of discriminations needed to establish trustworthiness. In other words, I am arguing that where the results of their work have direct impact on the public, scientists have a responsibility to engage with that public, providing a candid, accessible, and meaningful account of both their own findings and the implications of these findings, and responding to whatever concerns persist. I see no reason why this responsibility need conflict with scientists' responsibility to their own peers, nor do I see any reason why they cannot draw on the professional authority they've already established in extending that authority to a wider audience. If, for example, Freeman Dyson complains to the reader of the New York Review of Books that climate scientists tend to exaggerate the dangers, I'm saying that these scientists not only can, but are obliged to respond to explaining to that very same reader just why Dyson is wrong. Similarly, it is their responsibility to elucidate to readers just why the accounts of ClimateGate that have been put forth in the popular press are so misleading, to expose the intimate involvement of many of the scientific skeptics with vested business interests, to explain why the journalistic credo of balanced reporting can be so deceptive, just as they would proceed in their own internal referee reports. I realize that what I am proposing is far from a solution, but I think it might be a start. It requires climate scientists to take on responsibility for bridging the ever-widening gap between expert and lay reader, partly because they're the only ones in a position to take on this task, but also, and maybe more importantly, because their responsibility qua scientists obliges them to do so. Thank you.